Hi, welcome to Learn Machine Learning with ChatGPT. Here we have ChatGPT, and first you need to register and press login. You can register with Google, Microsoft, or Apple account, or with the email address. I already registered, so let's get started. First, let's ask what is a feed-forward network, which is the most simple network. And ChatGPT will give us answer. So there's an input layer, a hidden layer, output layer, and also for the input and output we have weights and bears. So let's have the mathematical expression to get it more precise. So the input layer is given by x, and the hidden layers are given by a matrix times output and plus a bears. And then the output layer is the final layer, in which you have this. And you can also write it in LaTeX. And we can have a collab, and you can write code, and also you can write test. So we can copy, first we rename the notebook, and then we add some test. So we have this title, and then let's copy the formula here. Yeah, and you can see what are the formulas. And next, let's ask, can give a code for one layer network, and which is the basic building block. So here, ChatGPT will generate a code, and then we can copy it to the notebook. And so there's a one layer, so it's just a linear layer, and with the input, and let's change output to 20. So you input a 10 layer vector, and you press forward pass, and you will get output. So you run the code by press here, or use Shift Enter, and then the output is a 20-dimension vector. Okay, so let's compute the number of parameters of this network. So because ChatGPT may not understand the code, so you need to give the input dimension and also output dimension. Let's give it 10 and 20. So to compute this, we have input dimension 10 and 20, so number of ways are the input size and output size, which is 200, and plus number of bears is 20, so total is 220. So we compute it in PyTorch, and you copy the last two lines. Yeah, it's exactly 220. So let's go on. Let's ask ChatGPT to give an example to do the meanest classification, which is classification of handwritten digits. Yeah. So ChatGPT will provide the code, and we can copy the code to collab. So let's understand the code. So you have some training data set and test data set, and some data loader, and some parameters, and the network. And then let's first copy this part for training to the next code cell, and let's first run this part. So let's visualize the data set. Yeah. So there's file samples, and it random tries some index in the training data set. So you copy it, and there's the image and label. So there's an image 1 to 9, and also label, which given because we need the label to train. And next, let's take a look at how to train. First, we define a loss. What is this cross entropy loss? So it's used in classification to compute the error between the true label and the model predictions. So it's defined by this, and also for multi-class, it's defined by the summation. So why do we need this loss? Because there's some probability, and also it's compatible with softmax activation. And, we can ask what is optimum value. So, yeah, you can take a look. And then we need to define optimizer. So let's ask ChatGPT what is an optimizer. So it tells you optimizer is actually to update the parameters, because there are lots of parameters in the network. And there's SGD, a DAM, and different of optimizers. Let's take what is a mathematical expression. So the simplest one is SGD, which is you update parameter theta to the next step t+1 and by the e-test learning rate, and gradient theta is the gradient. So let's ask what is learning rate. So learning rate, you need to choose a good one to make it converge, and also OS divergence, and also balance exploration. And then we input the image and label, and then the output, and then we need to compute the loss, and then ask the optimizer to update the parameter. So let's see why we need to first use zero gradient. So the main purpose is to clear the gradients. And with this one, you can use the loss backward to do back propagation and to compute the loss, the gradient of loss with respect to the parameters, so that you can use the optimizer to update the parameter. So for back propagation, in the first part of forward pass, compute the loss, and then use back propagation to compute the loss, and do parameter update, use optimizer, and do this iterative. Let's take a look at what's the meaning of the output. So the output is like here we have 10 class, so we have 10 vectors, and it denotes the probability. And so you choose the maximum probability to make predictions. Let's run the training process. Here you can see how long the program runs. It will take you a few seconds. And here is the loss. As you can see, the loss is decreasing, which means we are getting closer and closer to the true label. And because it's stochastic, so it's not strictly decreasing, but there's some fluctuations. Okay, let's take a look at the output. So it's actually vectors, right? Okay, so we can test the performance. So you have the predict one, and so you compute the accuracy. So they're 92%, which is pretty good.